So welcome to lesson number 5. We're on Refraction 2. We're on the first part of Refraction 2, 5.1, lenses. We're going to look at different kinds of lenses. So make sure you have your notes downloaded. And we're starting off that first section, 5, part 1. We've got 2 kinds of lenses we're going to be looking at here. We're going to be looking at convex lenses, also called converging lenses, and concave lenses. Okay, so let's get to it. So, we have our convex lenses. How am I going to distinguish a convex lens? Well, thicker at the center. And the other kind of lens is called a concave lens. It's thinner at the center. So that's how you'll recognize them. How do I manufacture a convex lens? How do I make it? Well, let's have a look at how I make a convex or converging lens. You see that there? That's a sphere. Say it's a solid sphere of glass. And what I'm going to do is I'm going to cut off that left part. I'm going to cut off that right part. I'm going to take those 2 pieces. I'm going to bring them over here. And I'm going to push those 2 pieces apart. So if you like, here's the joining line. The joining line is the line going down the middle. They're fused together at the middle there. Now, of course, that sphere has a center. And that center we call C. We call C the center or the center of curvature if we want to be a little bit fancy. And of course, these 2 parts of that sphere, they'll still have their center. There's the center there of the right-hand part. And the left-hand part has its center C there. If I draw a line through those 2 center of curvatures, perpendicular to the joining line, well, that line there is called your principal axis. So we've had that before when we did mirrors. That there is my principal axis. Well, of course, one of the things you want to know is what happens if I send a ray of light at that lens, what happens to it? And the ray of light we always take is a ray of light parallel to the principal axis. Let's try and find out its fate, where it actually ends up. So if I take a ray of light, I'm going to shine it. It doesn't matter, by the way, which side we shine it in. Because unlike mirrors, the light will pass through from left to right or the other way around. There is a ray of light, my incident ray, parallel to the principal axis. Now, what is going to happen to that ray of light? Well, I need to put a normal in. A normal is a line that's perpendicular to the surface. Now, how do I draw a normal to a part of a circle? Well, there's its center. A line, if I put my ruler at C to that point of incidence, that there is your normal, N. In there, you've got your angle of incidence. Now, what happens, we saw this in the previous lesson, what happens when the ray of light goes into a medium where the light slows down? Well, it's going to bend towards the normal. It's going to bend down like this. So you see that angle of refraction in there? That's smaller than the angle of incidence there. Now, it hits the second surface. It's going to go from glass to air. So if you look at the various media, that was air, A, that was glass, G, and now it's going to go out into air again. Once again, I want to draw a normal at that point of incidence. So how do I draw a normal to a circle? Well, I get my ruler and I connect that ruler to the center and the point of incidence. And that line there, that represents my normal. Now, what happens when a ray of light goes from glass into air, where it's traveling faster? Well, this time it's going to bend away from the normal. It's going to bend down, say, like this. So you can see, looking at that the angle of refraction here is bigger than the angle of incidence there. It's bending away from the normal when it goes from a slower medium into a faster medium. And that point that it passes through, that point is called the focus F. Now, the focus F doesn't have a straightforward relationship with C like before. Before, F was halfway between the pole of the mirror and the center. Well, in the lens, that relationship doesn't hold. So we won't be worrying about C when we do lenses. That center of the lens, once again, we call that the pole of the lens, or the center of the lens. So, you know, what we can say is rays of light parallel to the principal axis will be refracted through the focus on the other side. You can see why it's called a converging lens, because the rays of light come down towards the principal axis, whereas later on concave lenses, it'll bend up. That's why it'd be called a diverging lens. So let's go back to the other board. I can say that a convex lens is a converging lens. And later on, you'll see that the concave lens is diverging. And like we sometimes call it those names, we sometimes say a converging lens rather than a convex lens. You've got to be familiar with both. Well, here's my convex lens, and it has a focus. Let's say the focus is here. Obviously, there will be a focus on each side. And basically, I'm asking the question, what happens if a ray of light goes in parallel to the principal axis? Well, you know the way I had it bending twice? Once when it entered and once when it came out? Well, that's a bit of pain if you're drawing lots and lots of diagrams. So I suggest you do this. I suggest that we actually put a line, a dividing line, down the center of the lens like this. And we just have the ray of light bending about that line. Now, not strictly true, but it's an easier way to draw it. So when I have my ray of light coming in parallel to the principal axis like this, I'm just going to have it bending once about that central line, and it'll pass through the focus. That's an easier way to draw it, though you know what the true picture is. The true picture is it bends on entry and it bends on exit again. Equally, if I sent the ray of light from the right-hand side in, it would be refracted down through the focus on the far side. So it actually passes through that focus. That would be called a real focus. If I took another ray of light parallel to the principal axis, once again, that'll be refracted down through the focus. So all rays of light parallel to the principal axis will be refracted through the focus. Do one more. Ray of light parallel to the principal axis will be refracted through the focus on the far side. Okay, so you know the fate of the first ray. A ray of light parallel to the principal axis, what happens to it? It gets refracted through the lens, through the focus on the far side. So at the end of that first page in your notes, you have a number of what we call construction rays, because we want to see how do we form images in convex lenses. And in order to do that, we need at least two rays. So I've given you three rays here, ray A, ray B, and ray C. And these are three rays whose fate I know. I know what's going to end up happening to them. So let me have a look at these in detail on the board. So here's my three convex lenses. They've got a focus on either side. What's my first construction ray going to be? It's going to be a ray of light parallel to the principal axis. Now, we don't want to show it bending twice. So in each case, we put in that central line going down the middle. Central line going down the middle. We'll just bend it once about that line. If I take a ray of light going parallel to the principal axis, I'll just have a bending about that central light. What happens to it? It gets refracted through the focus on the far side. That's ray A. We'll always use that ray, by the way, for all our image constructions. What's my second ray? Well, what about the opposite of that? I mean, light is reversible. Light doesn't behave in a different way going in a different direction. So if I sent a ray of light back that way through the focus, what happens to it when it hits the lens? It'll go out parallel to the principal axis. Therefore, a ray of light going through the focus like this. What happens when that ray of light hits the lens? It will go out parallel to the principal axis. It's just the reverse of the first situation. And my third ray that I'm going to use? Well, a ray of light that goes through the optical center. It actually bends a little bit on entry and a little bit on exit, but at the end of the day, it goes straight through. So a ray of light at the optical center will pass straight through like that. That is my third ray. So we're going to use any two of those three rays to form our image in a convex lens. So let's have a look at how images are formed in convex lenses. Now you're going to draw these with me. So in your notes, you have these diagrams here. There's lots of different kinds of images formed in a convex lens, depending on where you place the object. Now, when we did mirrors, we had F and then we had C. And F was halfway between C and the pole of the mirror. There's no such relationship here for lenses. So what we're going to talk about is, we're going to talk about F and twice F. So we're going to put the object in a number of different positions. It's going to start outside 2F to begin with. There's my object, it's an arrow. Then I'm going to move it to 2F. And then I'm going to move it between 2F and F. And then I'm going to move it to F. And finally, I'm going to move it inside F. So you've got to be able to draw these ray diagrams. They should be fairly easy to draw because I've given you kind of grid paper behind them. So anyway, let's get to it by looking at them on the board. So let's have a look at image formation in a convex lens or a converging lens. Number one, the object O is outside 2F. So there it is outside 2F. I'm going to use any two of my three construction rays. It doesn't matter really which two you use, unless for a reason you can't use one of them. The first one I will always use, a ray of light parallel to the principal axis will go through the focus on the far side. I'm going to take a ray of light from the tip of the arrow. I'm going to try and find out where does the tip of the arrow finish. And then I'll assume all the other points in the arrow finish all the way down to the principal axis. If I take a ray of light from the tip of the arrow, that'll be one of millions of rays of light coming off the tip of the arrow. What happens to it? When it hits the lens, it gets refracted through the focus on the far side. That's my first ray of light. My second ray of light? Well, you can take either of two, whichever you prefer, from the tip of the arrow through the focus. What happens to it? It goes parallel to the principal axis. Or the third one you could take, from the tip of the arrow through the center, will go straight through. It doesn't matter which one you take. I'll take the second one, but I'll change. I'll vary it a little bit for other diagrams. So from the tip of the arrow through the focus, that ray of light there. What happens to it? That ray of light will go out parallel to the principal axis. And where does the tip of the arrow finish? Well, the tip of the arrow finishes here. And all the other points, therefore, will finish back towards the principal axis. So if the object is outside 2F, the image, which I'll call I, will be between F and 2F. It also looks smaller, doesn't it? That brings me to the nature, the properties of the image. Well, I'm going to have 3 properties just like we had for mirrors. You know this well. First of all, the rays of light actually meet. And if they actually meet, that means you're talking about a real image. Next, look at the size of it. It looks smaller. Smaller we call diminished. And finally, it's upside down. It's inverted. Well, actually, all real images will be inverted. If you know it's real, then you'll know it's also inverted. So that's the first one. Now we move on to the second one. All I'm going to do now is I'm going to move the object in a little bit closer, and you might be able to guess what happens. That image starts moving out the other way. Actually, if I move the object to 2F, the image will also be at 2F. That can be a difficult one to draw. So let me have a look at the second one. So the object is at 2F. Now, very hard to get your lines to meet exactly at 2F. So I'm going to do a little bit of creative cheating, I call it. I'm actually going to draw in my image first, and I'm going to make it exactly the same size as the object. I'm going to make sure the rays of light meet there exactly. It's a nice little cheating trick for your exam. Well, it's not really cheating, but I want to get my diagram spot on. So take my 2 rays of light, one parallel to the principal axis. We get refracted down through the focus on the far side. When doing that in the exam, I might adjust my focus a little bit. But actually, if you do it on graph paper, you'll actually have no problems. And the grid paper that I gave you in your notes, it'll turn out perfectly. And then what's my second ray of light? You can take either from the tip of the arrow going through F, by the way, when you're drawing this, it doesn't actually have to hit the lens. You're only drawing it for demonstration purposes. So you can extend that line down there and use that line if that ray of light happens to go down here. So you're only drawing the actual overall appearance of it. That ray of light will go out parallel the principal axis. And those 2 rays of light should meet exactly at 2F on the far side. And when you talk about the nature, what's the nature going to be? Well, the image is real, of course. And all real images are inverted. So if I know the first one, I can fill in the third one. And in this case, the image is neither magnified nor diminished. It is the same size. Right, let's move on to object position number 3. So we keep on moving the object in closer and closer. We've now put it between 2F and F. So once again, we'll take my first ray of light from the tip of the arrow, parallel to the principal axis. What will happen to that ray of light? It'll be refracted down through the focus on the far side. Now I'm going to take a second ray of light. I could take a second ray of light from the tip of the arrow, through the focus. Well, I could extend that line down if I wanted to. But it might be easier to take my third ray of light for some variety. So a ray of light from the tip of the arrow through the center of the lens will go through unrefracted. And extend this one a little bit more so they actually meet. So my two rays of light will meet down here. That's where the tip of the arrow finishes, and all the other points will finish back here. That's my image. You can see what the image is. It's formed outside 2F on the far side. You can also see it's magnified. It's a real image because the rays of light actually meet. It's magnified because it looks a lot bigger, doesn't it, than the original. And of course, all real images are inverted. Right, now we go on to the fourth one. So what am I going to do? I'm just going to move it in a bit closer again. So I'm going to push that object now to F. So here's my fourth object position. So my object is at F. So what am I going to do? First ray of light from the tip of the arrow, parallel to the principal axis. What happens to it? It gets refracted through the focus on the far side. Second ray of light. Well, I can't use the second ray of light, ray B, from the tip of the arrow through F. That'll miss everything. So I'm going to take my third ray of light, which is from the tip of the arrow through the center, and that will pass through undeviated. And you see those two rays of light there? They're actually parallel. They're never going to meet. So what kind of image will you get? Well, you'll get a kind of a blurry image. You know, I really can't talk about the nature. They're never going to meet, so I can't say it's real or virtual. I can't say any of those things. So I'll just say the image I is at infinity. It's actually going to be a blur. You're not going to see a sharp image formed because the rays of light never actually come together. So finally, let's go on to our last object position, number 5, where now we move the object inside F. This is the one that you really want to know. This is the one that they would ask you most often in the exam. So I want to see where the image is formed. To take my first ray of light from the tip of the arrow, you know the routine very well now. What happens to that ray of light? It gets refracted through the focus on the far side. Second ray of light, can't take my second ray from the tip of the arrow through the focus. It'll miss everything. So I'll take my third ray of light, which is a ray of light from the tip of the arrow through the center. Will pass straight through, undeviated. Now, if you have a look at those two rays of light, they're diverging. They're never going to meet on the right-hand side. But if I take someone's eye, you saw this earlier in mirrors. Here's someone's eye. In their mind's eye, they will work them back from where they came. So they'll work those rays of light back in a straight line from where they came. And these two rays of light appear to meet back here. The tip of the arrow finishes there. If I did all the other points in the arrow, they would finish down here. But I'm actually going to draw it as a broken line to give the impression that it's not a real image. It's only an image formed in your head. So what can I say about that image? What about its nature? Well, I can say it's a virtual image because the rays of light don't actually meet. You can actually see that in lenses, virtual images are formed on the same side as the object, whereas in mirrors, they're on opposite sides. There's one lets light go through, whereas mirrors bounce light back. It's magnified, looks much bigger, and of course, all virtual images are the right way round. They are upright. And do you know what you could use that for? As an application? That application is a magnifying glass. Like, you know, if you use a magnifying glass, you're looking at an object, you see the image on the same side as the object, but it's much bigger, and it's also upright. It can be used as a magnifying glass. That's the great application of that. Now, that is probably the hardest diagram to draw, but it's also the most important. That's the one they ask quite a lot in the exam, so know it very, very well. So let me have a look at the other lens, which is a concave lens or a diverging lens. That's what it looks like. Thinner towards the center and thicker at the edges. I'm not going to show you how to make one like I did with the convex lens. Now, what happens if I send in rays of light parallel to the principal axis? So, here's a ray of light going in, parallel to the principal axis. I'm just going to show it bending once. But because of the shape of the glass, when it goes in, it bends up, and when it leaves, it bends up again. That's the diverging part of it. So it's going to bend up like this. Now, it doesn't bend up in any old way. It bends up as if it came from a point called the focus. So there's the ray of light bending up. And if I work that ray of light backwards, it goes back to a point called the focus. Now that there is a virtual focus. Why is it virtual? Well, because the rays of light don't actually pass through it. They only appear to come from it. So when you do problems later on, that virtual focus length will have a negative value. All rays of light parallel to the principal axis will be refracted in such a direction as if they came from the focus. If I look at that one there, if I put my ruler at the focus to that point there, that line there will go back towards the focus. They'll bend as if they came from the focus. And of course, because light can equally pass through both ways, there will be a focus on this side as well. So that leads me on to my 3 construction rays. I just need 2 of my construction rays in order to form an image later on when I look at image formation. So here's my 3 construction rays. Well, the first one I've already done. A ray of light parallel to the principal axis. What happens to it? It will be refracted as if it came from the focus. Put your ruler like that. There's the refracted ray. If you work it backwards, it goes back towards the focus. Now, what's the opposite to that? Well, the opposite of that is a little bit tricky. But think about it. If I send the ray of light backwards that way, it'll follow the same direction. What's happened to that ray of light? It's actually heading for the focus on the far side, but never getting there. It never goes through the focus. A ray of light heading for the focus on the far side will be refracted out parallel to the principal axis. So, if I send in a ray of light like this, if I send in a ray of light heading for the focus on the far side, there's my ruler. So as I said, it's a little bit tricky. There's a ray of light coming in, and it's heading for the focus on the far side. It obviously can't make it. What will happen to it? When it hits the lens, it'll be refracted out parallel to the principal axis. That's your second construction ray. And you've probably already guessed your third construction ray. A ray of light going through the optical center of the lens, right through the middle of it. What will happen to it? It will pass through, undeviated. It'll go straight through. So there's my 3 construction rays. Just use any 2 of those to find the image in a concave lens. So let's look at image formation in a concave lens. The good news is there's only 1 diagram to draw. We don't have the 5 diagrams that we have to draw for the convex lens. And it doesn't matter where you put the object. You can put the object wherever you want. There's only 1 type of image formed in this. So let's have a look at it. Take a ray of light from the tip of the arrow, parallel to the principal axis. What happens to it? Well, it's refracted upwards as if it came from the focus. I work that ray of light back. Second ray of light, well, I go for the easy one. The easy one is from the tip of the arrow through the center, will pass through, undeviated. You have a look at those 2 rays of light there. Those 2 rays of light there, well, they're diverging. They'll never meet. But someone's eye may look at them, and in their mind's eye, they may work them back from where they came. So when we work that ray back and that ray back, they actually meet there. So the tip of the arrow finishes there. If I did all the other points, they would finish down there. So there's my image I. So what can you say about it? Well, I can say my image is virtual, of course. I can say it's diminished, and all virtual images are upright. So I can say it's virtual, diminished, and upright. What are the applications for that? Well, we'll see applications later on when we look at spectacles or glasses used to cure eye defects. Okay, so I think that's about it. This particular lesson. The next thing we're going to be going on to is, instead of drawing ray diagrams, we're going to be doing mathematical problems on this. So the one thing you have to do is, you've got to practice the 6 ray diagrams. 5 for a convex lens and 1 for a concave lens. Remember, convex is converging, concave lens is diverging.